In this video, we shall be looking at the modern history of the atom. At the turn of the 20th century, scientists came up with what is known as the plum pudding model of the atom. Here is a diagram of the plum pudding model. As you can see, it is called plum pudding model as it looks like a plum pudding with the raisins represented by red dots scattered throughout the green pudding. Small spears of negatively charged electrons on surface of green spear, large green spear of positive charge. However, this model had to be revised when in 1909 the famous Rutherford Lab alpha particle scattering experiment was carried out. Here is a diagram of the apparatus used in the experiment. On the left-hand side with the green box, we have the radioactive alpha particle source, positive charge. We have a circular screen in purple that will detect any deflected alpha particles. In the middle of the circular screen, we have a gold foil containing gold atoms where the beam of alpha particles will hit. Any deflection can be detected as now shown. Please remember that an alpha particle is composed of 2 protons and 2 neutrons, so it has a positive charge. So what was expected? Alpha particles would mainly go through the gold atoms or be slightly deflected by electrons if the plum pudding model of the atom is correct. Now, what was observed? Most of the atoms went straight through, which suggests the atom is mainly empty space. Some were deflected by different angles. Few were deflected straight back. This suggests the center of the atom has a strong positive charge, as the alpha particles that would deflect are also positively charged. We are going to finish off this video by looking at a simulation of the alpha particle scattering experiment. On the left-hand side, we have the alpha particles in green, and on the right-hand side, we have a single gold nucleus in blue. The first alpha particle will approach the gold nucleus head-on, and so will be deflected straight back. The next 2 alpha particles will approach the gold nucleus at a very close distance, and so will be deflected by a large angle. The following 2 alpha particles will approach the gold nucleus at a close distance, and so will be deflected by a smaller angle this time. The final alpha particles will not approach close enough to feel any significant electrostatic repulsive forces between them and the gold nucleus, and so will travel in a straight line to the detector screen.